Do you like books? I mean, really, really like books? Then you're in the right place. Each week, your host, Sam Hankin, interviews the best of today's top-selling authors and the up-and-coming superstars of modern literature. This is The Avid Reader. Here is your host, Sam Hankin.
Hi, everyone. Welcome to another edition of The Avid Reader, brought to you by Wellington Square Bookshop. Our guest today is Kenneth Miller, author of Mapping the Darkness. Its subtitle is evocative of what you'll find inside. The subtitle is The Visionary Scientists Who Unlocked the Mysteries of Sleep. It was published by Hachette, released in autumn of last year. Ken's works has appeared in, among others, Time, Life, Esquire, Rolling Stone, Mother Jones, Discover. Actually, Discover is interesting because it's kind of how the book starts. I say the subtitle is evocative because this book is as much, maybe more, about the people who reinvented our understanding of sleep and sleep itself. As the New York Times said, the book is a propulsive, utterly engrossing history of the subject, seen through the prism of four of its prominent contributors: Nathaniel Kleitman, Eugene Aserinsky, William Dement, and Mary Carskadon. And they're all like kind of related to each other in a way. So what is sleep, and why do most of us spend a third of our lives doing it, experiencing it, living in it, conscious or unconscious of it? It's really probably the strangest thing ever. Imagine an alien civilization watching our planet and its occupants as for 8 hours out of a 24-hour circadian cycle, they lie horizontal on a wooden framework covered in textiles, much as they would if they were observed deceased. And his study is a little bit like the old cliche: everyone talks about the weather, but no one does anything about it. And like the weather, sleep was accepted, still is, just as is breathing or procreating. But unlike those instinctive, reflexive, or biological imperatives that have been studied infinitum for millennia, sleep, although thought a lot about from the ancient Greeks to Freud, but the idea of like experimentally validating a hypothesis through hard work, especially for Kleitman, who ended his own magnum opus on sleep by basically saying, yeah, I may be wrong about this. This is a hypothesis, but better double check me. That experimental journey with primitive equipment and little funding, your science kind of swept under the corner of academia's rugs, if you will. It's kind of what this book is all about. It's an ongoing journey. It's studied now by those who stand on the shoulders of the four visionaries that the subtitle introduces us to. So welcome, Ken. Thanks for joining us today.
Thanks for having me.
Hey, so the reason I said discovery was interesting is because talk a little about the introduction about the gentleman, Mr. Burelli, and the guy you interviewed for Discover.
Yeah. So this book grew out of an assignment for Discover magazine back in 2013. It was published in 2015 on the latest latest discoveries in sleep research. And up to that point, I really hadn't thought a lot about sleep, except for when I had to pull an all-nighter to finish an assignment. I thought I was getting enough. I was kidding myself. I was getting about 6 hours of sleep a night because somebody had told me that that was enough. And I was kind of fried all the time, frazzled. But this assignment really opened my eyes to a couple of things. One is just how sleep is a central regulator of our physical, cognitive, mental, and emotional health. And also just how personally it can be just like a matter of life and death to get a good night's sleep. And the person who really brought this home to me was this guy, Joe Burelli, who I interviewed for the story. And Joe had been a successful radiologist. He ran 2 practices. He played a great game of tennis. He was the father of some young kids, was involved in national organizations in his field, like a really super competent guy. But around in his mid-40s, he started basically, as he put it to me, losing his mind. He started becoming forgetful. He would get lost on the way home through his suburban neighborhood. He was forgetting the names of his kids' friends and their parents and his fellow Cub Scout leaders. He would forget to do errands for his wife. Being a doctor, and he also noticed that he was feeling fatigued a lot of the time. And he put these two things together. and realized, first he thought, okay, this could be Alzheimer's, some other neurocognitive disorder, neurodegenerative disorder, but it could also be sleep apnea, because he knew that fatigue coupled with cognitive decline can mean you're having this breathing problem during the night that wakes you up hundreds of times a night. You don't remember any of it, but it has a terrible effect on your overall health and your cognition. So he went to a sleep center to get himself tested, and weirdly, he tested normal. So he went back to his routine, got more and more forgetful, started having trouble thinking straight, eventually also started having physical problems where he couldn't get up from a chair without getting winded. He couldn't cross a room without feeling dizzy, couldn't button his shirt cuffs because his fingers got really clumsy. He was just really falling apart. And he had to give up some of his professional work, and his marriage fell apart. His wife said, I'm sick of dealing with this. I don't know what's up with you, but I'm out of here. And he started thinking about suicide. And one day he just collapsed in the shower weeping. And, that was like rock bottom for him. And then he got up, dried himself off, and decided to see another sleep specialist, the best one he could find. And that was a guy named Christian Guilleminot at Stanford. And Guilleminot was one of the people who defined sleep apnea in the 1970s. An absolutely brilliant guy, was at that time probably in his late 70s. And Burelli flew out from his home in Atlanta to visit with Guilleminot at his office at Stanford. And Guilleminot took one look down his throat with a flashlight and said, I know what you've got. It's not sleep apnea. It's something that we call UARS, which is a restriction on breathing rather than apnea, which is when your breathing stops during the night. Guilleminot told him to go back on this remedy called CPAP, which is, as many of us know, sort of like a tire pump that inflates your throat to keep it from collapsing during the night, but at a much higher pressure than he'd been doing before. And Burelli started to get better. And all of the symptoms that he'd been experiencing, including super high blood pressure, which he'd had since he was a kid, vanished. And he was able to resume his career. He got a new girlfriend. And after several months of treatment, he had his life back. So that story really made a deep impression on me. And it made me wonder, how did scientists figure out this stuff? How did I had been looking at the latest findings, but what was the history of the field? And when I went looking for a book on that topic, none had been written for lay readers, and I decided to do it myself.
And it's funny because, Burelli is like, he's contemporary. You're talking about him like he's just one of us, which he is. But it's like Marvel Comics. On all these four guys, you go back to their origin stories. Absolutely. And it's really interesting. I didn't expect that, I expected a lay science book that would be interesting, enthusiastic, but would talk specifically about the science, not the people behind it. And so for each of these guys, women, and the one incredible woman, you go back to their very beginnings, to their childhood, and also not only then to their science, but how their childhoods and their youth might have affected the way in which they approach the actual science. So we might as well start with the first, Kleitman, who led to the others.
Yeah, and I will say, apropos of what you just said, somebody who read the book told me really they thought of it as a biography of sleep science. Because it really is about how this science went from this sort of wobbly, awkward youth, to this sophisticated, powerful adult over the course of a century. And that began, as you say, with Nathaniel Kleitman. And Kleitman, you have to go back to his origin stories, I think, because it helps illuminate how so much of scientific discovery comes through serendipity and comes through the lives of the scientists. We're not really taught that those two things are intertwined, but in my experience as a science journalist, I think they really often are. And so if you look at Kleitman's life, he was born in 1895 in the Russian backwater of Kishinev in what's now Moldova. And he was, when he was 8 years old, he survived a terrible pogrom. He was from a Jewish family and was dealing with the incredible persecution and anti-Semitism that was happening in Russia at that time. So his family survives this terrible massacre. It's clear from the beginning that this very precocious, brilliant kid has got to get out of there if he's going to, not only survive, but accomplish his potential. And so he goes on a false passport. He escapes Russia because Jewish kids in those days of draft age were not allowed to travel abroad. And so he gets on a false passport. He makes his way to Lebanon to go to medical school, intending to practice medicine in Palestine. But after a couple of months there, all the Russian students at this school in Lebanon are taken prisoner of war. And he manages to escape. He's rescued along with his classmates by an American battleship, which takes them to Greece. And from Greece, he hops on a steamer and lands at Ellis Island in 1915. So, this is a guy who's uprooted. He's just another, immigrant carrying a battered trunk. And within 10 years, he had founded a new branch of biomedical science. And the reason he did that was because when he entered academia in the 1920s, anti-Semitism was also a huge thing in the United States, including in academia. And for Jewish scholars, if they wanted to make it, they had to find a field that was not already dominated by the ruling caste, essentially. They were not welcome in established fields, and that was whether in physiology, as Kleitman was interested, or anything else. So they had to find something new to do. And Kleitman, while he was looking for a concentration for his physiology PhD studies, happened upon a book, the only scientific book about the state of sleep science up until that time. And very little had been done, but some had been done. And all of it was really tantalizing and fascinating. And Kleitman said, this is where I want to go. There was at that point no such thing as a full-time sleep scientist. And Kleitman said, I want to be the first one. I want to go all in. Unfortunately, he had a supportive PhD advisor who said, go ahead, but nobody's going to be able to advise you on this. You're on your own. And that's what he did. And for 30 years, he was the only full-time sleep scientist really in the world. But so Kleitman's launching of this new field, he's considered the father of modern sleep science, really grew out of his personal experience and the larger history that was happening around him. And that to me was really essential to the way I wanted to structure the whole book.
And it's funny that throughout there's these, we could go on just on Kleitman's first 10 years and take a couple hours doing that. But one of the little things I wanted to bring up is when Kleitman is doing his research, there's this other guy, he's kind of like a P.T. Barnum guy. Talk about him, because that's it's so funny that just kind of is in there, but it's really funny and it's good that it's in there.
So at that point, sleep science, to the extent that it existed, it was sort of a secondary interest of people in various fields like psychology and physiology. And the experts, there were a few people who were self-styled experts on the field, but they really knew very little. And some of them really liked to expand on things, that went somewhat beyond the evidence. So the P.T. Barnum guy you're talking about was actually named Donald Laird. He was a professor of psychology, I believe at Colgate, and he was an expert on almost anything you could think of. He was giving the newspapers quotes about temperance, about labor unions, about the relations between the sexes, anything at all. And he glommed on to sleep as kind of a cool thing that he would get involved in. And he started in a dorm at his college, a sleep lab. And he was doing all sorts of experiments, but they weren't really well structured, and they didn't really tell you much beyond that, something interesting was going on here. But then he would go to the newspapers and write columns about what it really meant. And what to him, it meant things like, for example, his observations had told him that women sleep better than men. And that the reason for this is because they ate more candy, because carbohydrates help you sleep. It's total just nonsense. But he managed to convince a lot of people about this. He concluded that on the basis of questionnaires that he'd given out, that most people don't dream, or they dream only very little. Well, of course, people don't remember their dreams, and probably his questionnaires weren't well designed. But he was regarded as like the leading sleep expert in the United States in the 1920s and 30s, before Kleitman rose to prominence. And he
I was going to say, the other thing is like, and that happens today too, but the other thing that happened then that still happens is like Ovaltine, funding scientists in order to prove that Ovaltine might help you go to sleep, or even later on, like the beef counselor or something saying, find out whether protein in the morning, protein before bed, which goes back to Charles Dickens. Okay. So anyway, talk about that too.
Well, sure, because the thing about Kleitman was, unlike, there were a small number of physiologists and psychologists who were studying sleep part-time as a sort of a sideline. And then there were guys like Laird who were more focused on it, but were really, to some extent, charlatans or quacks. There were also psychologists who said sleep is a primitive habit that we can learn to overcome. If we just cut back on it 5 minutes a night for several years, we could, get down to like just having to sleep an hour a night, or maybe not at all, because it's something that's a throwback to the cave days. Kleitman was not like that. Kleitman was a really serious scientist. And for him, the science came first, and he wasn't really interested in fame or notoriety. And he was very, very cautious about declaring any conclusions before he had proved it in every way possible. And even then, he would say, this is tentative. This is until it is disproved. This is what the evidence suggests. He was a genuine scientist. And so this sometimes led him into conflicts. For example, in the 1930s, during the Depression, there was very little, there was never much funding for sleep science, but in the 30s, it was funding for all kinds of science was cut back due to the Great Depression. And so in his lab, they started taking funding from the company that made Ovaltine, which, as you may know, is a hot chocolate mix, which is fortified with various ingredients that at the time were reputed to help people sleep. And so Kleitman, with funding from the company, did some testing, and he found that if people who took 3 teaspoons of Ovaltine in their drink each night slept a tiny bit better than people who took no Ovaltine at all. If you took the recommended dose of Ovaltine, which was 2 teaspoons, it really made no difference at all. And this is what he reported. However, the Ovaltine company said, aha, University of Chicago scientists proved that Ovaltine helps promote sleep, and ran this ad. And Kleitman was outraged and demanded that it be withdrawn, and the company did withdraw it. And this is just the kind of thing that he was really very serious about.
Yeah, it's funny that his personality was interesting, because you made it very clear, both with him and Aserinsky. Kleitman and Aserinsky I didn't know anything about him before. So after I read your book, it seems like, well, they didn't get along. They weren't the best of friends. It was like Lennon McCartney versus McCartney Lennon in terms of the Beatles. And then, Dennett was he was an unwanted assistant, and there's personalities there too. How did you even find out about that?
So Aserinsky, so I'll tell you about Aserinsky and how he came to be involved in all this. So Eugene Aserinsky was the guy who discovered rapid eye movement, or REM sleep. And he had never meant to be a sleep scientist. He wasn't really interested in sleep. He wanted to be an organ physiologist. He was a guy who came to the University of Chicago at the age of 27 after bouncing from job to job. He'd gone to dental school for a while, but decided he didn't like dentistry. He'd worked as a social worker. He'd worked in an ice packing plant. He'd done all sorts of stuff. And finally, with the GI Bill money, he was very brilliant, but very unfocused. And with GI Bill money, he decided to go get a PhD in physiology at University of Chicago. He shows up, and the only advisor available was Nathaniel Kleitman, who specialized in sleep, which Aserinsky thought was a literal snooze. It's like, I'm not interested in sleep. But reluctantly, he needed an advisor, and he went to work as Kleitman's lab assistant. And Kleitman at this point had gotten interested in eye movements during sleep, really in blinking before sleep, because he'd read somebody had published a study in a science journal observing that people stopped blinking suddenly as they were falling asleep rather than gradually. And he wanted to see if it was true. Very abstruse, very obscure thing. Aserinsky thought it was just completely a worthless thing to pursue, but he did it because he needed to. And he was not able to really, he started out doing it with adults. He couldn't really measure it. He went to doing with infants, and he couldn't measure their eye movements very well, but he did discover an interesting thing as he was studying infants, which was that for 20 minutes out of every hour, their eyes stop moving. So during, as they're lying in their cribs, they seem to be maybe dozing and their eyeballs are moving slowly, but for 20 minutes, their eyeballs stop moving. Nobody had reported that before. He thought, well, this is interesting. And he did a little study on it. And Kleitman said, okay, fine. Why don't you study eye movements in sleep in adults? What can you do? And Aserinsky said, well, maybe if I watched the eyeballs of adults all night, which nobody had ever done, something interesting would come up. Didn't know what, but he also thought, there's this new machine that's being used in medicine called an EEG machine. It was invented in the 20s, came into use in the 30s. But nobody had looked carefully at what your brain waves were doing during sleep. They'd looked at it a little bit, but nothing conclusive, and nobody had followed that all night. So he thought, what if I hook people up to this machine called a polygraph, which can measure their eye movements, the electrical impulses created by their eye movements, and measure their brain waves, and watch them all night long, and we'll see what we come up with. Maybe there'll be an association between changes in eye movements and changes in brainwaves. And what he found when he hooked up his 8-year-old son, Armin, to this machine was, to his astonishment, there were regular periods during the night in which Armin's eyes were not only moving, they were darting back and forth really vigorously, as if he was watching a game of tennis or something. And at the same time, his brainwaves were charting patterns that looked almost exactly like those during waking. Nobody had seen that before. And especially the fact that that was happening together and that it was happening several times a night was really strange. And Aserinsky then started experimenting with more people, and he discovered this was happening basically with everybody. And in 1953, he and Kleitman published a paper with Aserinsky as lead author, reporting on this new form of eye movement during sleep, and they called it they came to call it rapid eye movement sleep. And the thing about this that turned out to be revolutionary was that this meant that at regular intervals while you're asleep, your brain is as active as it is during waking. Nobody had suspected that before. Maybe a few people, but nobody had really, that was not something that was ever on anybody's minds. What that meant was that sleep was really interesting, because for decades, one of the reasons so few people studied sleep is because it was regarded as a period of quiescence. It was a time when very little happened. Dreaming was probably, what Kleitman thought dreaming was about was that your brain was mostly shut down during sleep. And if you felt discomfort or hunger or something like that, your dozy brain would interpret that and make a story around it. What Aserinsky found was that this rapid eye movement period, when he woke people who were having REM sleep, they told him they'd been dreaming. And sometimes when they weren't having REM sleep, they also had dreams. But much more frequently during REM sleep and much more vivid. They told stories, dreams that were really narrative and colorful versus the kind of dull ones they told during other stages of sleep. So something really interesting was happening in the brain during sleep. However, Aserinsky got along so poorly with Kleitman because he had troubles with his own father, and he regarded Kleitman as sort of an oppressive patriarch, that he quit the field before his study even came out. But Kleitman had given him as his assistant a young medical student named William Dement. And Dement was a guy he was kind of a bohemian. He played jazz bass, and he was really into Freud. And he was a devotee of Freud's theory that dreams are the royal road to the unconscious. And so Kleitman said, hey, Bill Dement, why don't you go work with Aserinsky, help him out in the lab? And Dement, while helping Aserinsky in the lab, became utterly fascinated with sleep, obsessed with it, and particularly with REM sleep and how you could measure dreaming and maybe use that in psychoanalysis. And his theory, what he thought he could possibly prove is Freud's theory that dreams are a safety valve for unconscious desires and impulses that would otherwise erupt into waking consciousness as psychosis. And Dement, after Aserinsky left, basically spent the next 20 years trying to prove that theory. First, in Kleitman's lab, where he did measurements of REM sleep that were more precise and more revelatory than anything that had been done previously. And then at his own lab, eventually at Stanford University, where he went in 1963. But Dement eventually had to concede, you know what? No, dreams actually don't seem to be a safety valve. There, people who are prevented from REM sleep, which is what he did, was he deprived them of REM sleep. They don't go crazy. They're fine. But in the process, he discovered hugely important things about how the brain and the body interact during sleep. And this allowed him to found the field, which is now known as sleep medicine, which he started doing in the early 1970s.
You know, as I read through, especially in the early days when there wasn't any money and there weren't a lot of people to use as a part of the experiment, it was really strange how they would experiment on each other and also on their children, especially when Kleitman was using electric rectal thermometers. And I'm thinking, this is not really good science. This is not a good idea, both for the kids and what kind of quantitative, empirical, epistemological results can you derive when you're experimenting on your own self or your colleague when there's no control?
Yeah, and Kleitman's most famous experiment, besides helping Aserinsky discover REM sleep, was in 1938 when he and an assistant spent a month in Mammoth Cave in Kentucky trying to change their sleep wake rhythms from a 24-hour cycle to a 28-hour cycle. Kleitman had done experiments in the lab trying to change people's sleep cycles because that was what he was really fascinated with, was sleep rhythms, and they were inconclusive. And he thought, one of the reasons that, it seems like some people were able to adjust their schedules, other people weren't. It wasn't clear how or why. And he linked whether people could adjust their schedules to whether their body temperature fluctuations changed along with their sleep cycles, because your body temperature generally changes a degree or two during hits a low late at night and a high in the afternoon. So he had been doing these experiments, and he decided the best way to do the experiment was go somewhere where you didn't have external cues of day and night. So he was trying to do a controlled experiment because he thought maybe one of the reasons for these differences is that some people are more sensitive to those cues than others. Maybe it's an environmental thing. So first he decided to go to the Arctic region during the summertime when it's always daylight, and maybe that would teach him something. The problem was that it was the middle of the Depression. There was no money. He couldn't afford to go to the Arctic. And a colleague said to him, what you could do that's cheaper is go to a cave. And this colleague was a geologist. He said, Mammoth Cave in Kentucky is the biggest cave system in North America. It was just being taken over by the national park system, and you could probably get a chamber there where you could isolate yourself for a long period of time. So that's what he did. Spent a month in Mammoth Cave with a young assistant trying to change his sleep-wake cycles, but it was a very poorly controlled experiment, in part because there were only two people. And what can you tell from two people? Well, actually, you can tell very little. And in the end, Kleitman's assistant was able to change his sleep-wake cycle. Kleitman was not able to, but he really couldn't say exactly why. But what that experiment did was it created a media sensation. Newspapers and newsreel filmmakers started coming down to the cave and visiting Kleitman, and it made headlines across the country, and it brought sleep science into public consciousness in a way that had never been done before. As science, it wasn't so hot. And the thing is about Kleitman is Kleitman laid the groundwork for all these people who came afterwards. And Kleitman came of age in an era when self-experimentation, experimenting on your loved ones and so forth, was completely normal and accepted. Things tightened up a great deal in subsequent decades, but that just wasn't the state of the science at the time. But he made a beginning which allowed other people with better technology and cleaner scientific methods to really answer some of the questions that he had posed so brilliantly in the decades before.
It's funny, it brought me to current kind of cancel culture thing, because the early experimentation, and still now, relied so much on dogs and horrible things that they did to them. And today people might condemn Kleitman for doing that, but it was obvious, as you said, accept it. The one thing that really bothered me was the picture in the book of him sitting with one of his experimental dogs, being so affectionate to it.
Yes, yes. So, in the days before cell cultures and all the other things we have now to simulate in computers, I mean, we can simulate so much now that happens in people's bodies and their brains. But in those days, you really couldn't. And from the really beginning of physiological science, the only way pretty much to figure out how different states of being, different variables affected an organism without experimenting on people, which was universally regarded as ethically tricky, was to do it on animals. And this was just like so many of the great breakthroughs in terms of medications and vaccinations and so many other things were carried out on innocent dogs and cats and rats and anything else that scientists could get their hands on, because I think there's a loyalty to our own species, and philosophers at that point would say, if it's going to benefit our species, then the suffering of other species is worth it. That was just the dominant way of thinking. So it was possible to be a very humane person who loved dogs and cats on a one-to-one basis, but who also felt that this mission of curing human diseases, of making human life better, justified the sacrifice of a small number of these animals. There were no regulations on that sort of thing. The philosophical thinking about that had not evolved to the point where it is today. And so Kleitman experimented on dogs in ways that were really painful for the dogs, but he loved dogs. Later on, Dement experimented with cats, and Dement was of a different era. He was in the 60s, and he really wanted to minimize the suffering of the cats. And so although he would keep them on treadmills all day and so forth, he would give them breaks, make sure that they were played with. When they retired, he would make sure they were adopted by good homes. He even had a sign up in his lab saying, TLC is central. Make sure you give affection to these cats because they need it. Michel Jouvet, who discovered really important things about how the brain works in sleep, did so by dissecting the brains of living cats. He was a cat lover. He had several pet cats at any point, gave them all names, and they ran around his house, lavished them with affection, and yet in the lab, he had a different standard. And it's one of the paradoxes of science, and I would say one of the paradoxes of human consciousness, that we're able to hold such radically different attitudes towards the same beings that we share the planet with.
Yeah, I agree completely. Especially the one experiment where they simply decide, hey, let's just sever the cerebral cortex from the brain. It's like offhand, let's give this a shot.
Yeah.
But it's not a very thing to do to somebody. But it's funny you mentioned the word consciousness, because in the review by Samantha Harvey, who wrote a book about being sleep deprived for basically a year, she talks about basically what's become the word that everyone cares about in sleep research, which is REM. And rapid eye movement in her review is basically where it's at. And for me, interviewing scientists for the past 5 or 10 years, philosophers, psychiatrists, neurosurgeons, about basically the seat of human consciousness, sleep comes up now and again, because I think you have a quote in there from a religious about the idea that you dream you're something and then you wake up. It could be that you wake up into the dream that, was the reality that is now the dream. And that always brings to me the idea of, okay, how can any of us, especially when you're working on yourself, how can you define where human consciousness lays and what human consciousness is? And it goes back to Descartes.
Yes, it does. It goes back to Descartes, and it's something that we're still trying to figure out today. And yeah, so I mean, one of the things that Dement, when he was looking at REM sleep early on, he said one of the crazy, wonderful things about this phenomenon is it shows that we can be conscious while asleep, just as people in some states of neurological damage can be unconscious while they're awake. And it really sort of, fuzzies up the edges of what we consider consciousness, unconsciousness, and the meaning of that state. Of course, he didn't come up with anything definitive to explain those differences, but he raised questions that are really, really fascinating that people still are grappling with today.
Yeah, and it's like the whole concept of dreaming. As much science as there's been done about it, there doesn't really seem to be anybody who has an answer or a definition of what dreaming actually is.
Yeah. I mean, there's in fact great debate over how important dreaming is and what purpose it serves, but sleep in general also. I mean, because there's so many different theories of why organisms evolved to do this thing. Pretty much every organism with a nervous system does something like sleep, and where exactly the boundaries are cut off is not quite clear, because there's strict definitions of sleep which involve assuming a certain body position, which involve being harder to rouse during this state of rest, which involve things like that. And not all animals that sleep do it the same way, right? So, dolphins can sleep one brain hemisphere at a time so they can keep swimming. One of the definitions of sleep is supposed to be that if you're deprived of it, you need more of it or a deeper state of it in order to make up for that deprivation. And that's generally true, except birds, when they're migrating, can go without sleep for weeks at a time, and they don't seem to need to make up for it. So, there's this question of like what really counts as sleep, though even jellyfish seem to do it in one way or another. But then there's also the question of why did it come into being? And some of the early ideas were, well, it was to keep us from wandering around at night, so that we wouldn't fall into holes or get jumped on by predators who had sharper eyesight than we did. There's also just the obvious idea, well, maybe it's to conserve energy. If we were awake all the time, we'd have to eat more calories, and so this is a way of forcing us to conserve our energy, and therefore making our survival more likely. Maybe, but then as more and more became known about the brain and how it works, it became clear that during sleep, the brain is doing all sorts of very strictly programmed activities, which seem to have to do with offline maintenance, is what you'd call it. So certain parts of the brain shut down, so that, for example, it seems memories are consolidated. Excess synapses, the connections between neurons, your nerve cells, are pruned away. And so that things that you've learned during the day, only the important things that you really need are maintained, and you don't get overloaded. All sorts of experiments have shown that people deprived of sleep learn more poorly, forget things. Also, if you're trying to get over traumas, deep sleep seems to help lessen the emotional impact. And if you can't do it, you can end up with PTSD. All these things are going on, but which is primary? We still don't know. We still don't know why this thing arose. And there are even scientists who say, oh, REM sleep dreaming, it's really not important for any of those things. What it's really important for is evolutionarily, your brain operates at a higher temperature during REM, and it just has to do with during sleep, animals had to be able to wake up easily if they were threatened by some danger, and REM sleep periodically brings them to a state where their brain is warmer and can spring into action more quickly. And that debate is still going on. So all sorts of, again, fascinating questions have been raised. Some insights have been gained into the answers, but debate continues to rage over the essential meaning and purpose of sleep.
Yeah, it's funny how the EEG machine basically began because, people were trying to determine why someone was a telepath, or why I thought her brother died when the wagon wheel just almost hit him. And so even now, it doesn't, maybe I'm completely wrong, but it doesn't seem like we've come that much further, because it's not something like mathematics or quantum theory. It's something that has these really soft edges around it, like clouds almost, that doesn't, it seems as if it doesn't want to be discovered almost.
But it does. I mean, if you want to anthropomorphize, you certainly can, and it's hard to avoid it. But yeah, and hold on, I lost my train of thought here, so you're gonna have to do an edit.
That's all right.
But go back and give me the last bit of that thought.
Okay.
So I can respond.
Take your time. So I forgot what I was saying too.
Yeah.
You were talking about anthropomorphizing. What I was saying was this. We are at 52:30. My producer gets mad if I don't write down the time.
Yeah.
So what I was saying was, it seems as if sleep is so ill-defined and so soft around the edges, almost like a cumulus cloud, that it almost is hiding from discovery, unlike something like quantum mechanics or the laws of thermodynamics, which can be quantified. And as I was saying before, there's epistemological, empirical data. And here, even though these guys tried really, really hard, it doesn't seem like you can pin it down.
Yeah. It's mercurial. It's the kind of thing where you can pin down little parts of it, but they still manage to wriggle out from under the pin. And so it's an incremental process of learning more and more. And so much of this also, you mentioned that the EEG machine grew out of a desire to understand what was thought of as telepathy. Yeah, so the inventor of the EEG machine, Hans Berger, had an accident. He fell off a horse while on military maneuvers in, I think, 1893 in Germany, and his sister or his father wrote to him that night saying, your sister thinks you had a terrible accident. She's really worried about you. Please let us know if you're okay. And so he thought, my God, this is incredible. This telepathy. I'm going to switch from studying astronomy, which he had been doing in college, to studying psychology, so that I can get to the essence, figure out the physiological origins of what he called psychic energy, which is what was generally called that in those days. There was very little, the lines between hard science and soft science and pseudoscience were really not quite clear at that point. And he spent decades trying to measure psychic energy, and in the process invented this incredibly useful machine called EEG machine, which can measure your brain waves, and which finally came into use in the 1930s. But that kind of serendipity is just universal, not only in sleep science, but also in science in general, I think. There are many other instances, including Dement deciding to study REM sleep because he was interested in Freud's theory of dreams. Freud's theory of dreams is brilliant, and if you're in therapy, it can probably help you quite a bit because it gives you something to free associate off of. There's no scientific there's not really strong scientific evidence for it. For much of it, there's no scientific evidence. It sort of intersects with actual science in a few different places. But by going after this idea that, had limited validity, Dement managed to find out incredibly useful stuff. He eventually gave up on his original reason for investigating this stuff, was able to turn it to great practical and educational effect. And I would say serendipity also, that also extends to how people get into sleep science. And that I want to make sure we bring up the fourth member of the quartet of my biography, which is Mary Carskadon. Mary Carskadon illustrates how people who initially had no interest in science can wind up making huge contributions. So Carskadon was a young woman from a very sort of classic, ordinary American family. Her father was a military reservist and a civil servant. Her mother was a homemaker. She grew up in the suburbs in the woods around Pennsylvania. Showed what somebody might have been able to see as signs of great intelligence and energy and original thinking as a young girl. But because she was a girl, nobody was interested in cultivating that. So, when she was, I think, 11 or 12, she went to the library. She got really interested in the human brain. She said to the librarian, "Do you have any books on the brain?" And the librarian said, "Sorry, honey, we don't." If she'd been a boy, I'm sure she would have gotten a book. She wound up going to college, not quite sure what she wanted to do, interested kind of in psychology, but also in literature, graduated, and wound up working in William Dement's lab as a lab assistant because her mother was the cousin of Dement's wife. It's a family connection. And her father had said to Dement, "Hey, my daughter's a little lost right now. Could you hire her?" And Carskadon traveled across the country to go to work in the lab at Stanford. And when she got to Stanford, Dement, first of all, realized, he started just putting her in charge of small things in the lab. And he immediately recognized, wow, this woman is super intelligent and really competent and amazingly organized and really good at connecting with people and a really good writer. What can I do with her? And he started giving her more and more experiments, more complex experiments to do and training her. And she just rose to the challenge like a champion. And soon she got really excited about science. And she wound up going for a PhD at Stanford. And while still a PhD student, she discovered or really invented a way to quantify drowsiness experimentally. This had never been nobody had ever done that before. If you wanted to know how sleepy somebody was after a sleep deprivation experiment, for example, or after they'd taken a sleeping pill the previous night, you had to ask them on a questionnaire, how sleepy are you? It's very subjective, very, very inaccurate. She realized that if you deprive people of sleep for a certain amount of time, they're going to fall asleep much more quickly during the day. And so she developed a test called the multiple sleep latency test, or MSLT, which is still used today, where you put somebody in a darkened room every 2 hours during the day and say, try to sleep. And then you measure using an EEG machine how quickly they fall asleep. And that's the way to measure drowsiness, still used today. She then went on for her thesis she got very interested in sleep as a developmental thing and how it changes as kids develop. And she set up an experiment that ran for 10 summers in a row called the Stanford Summer Sleep Camp, at which she measured kids' sleep needs over subsequent summers as they matured from childhood into adolescence. And she discovered, something that was completely counterintuitive. Up until that point, it was thought that small children need the most sleep. Adolescents are on their way to adulthood. They need less sleep. They need pretty much the same amount as adults. And people had noticed that teenagers like to stay up late and sleep late. Anybody who has a teenager knows that. But they figured it was for social reasons, because they had more active social lives, because they had more homework to do, because that's what their peers were doing. She set up a bunch of ingenious experiments that showed no, actually adolescents need just about as much sleep, in some cases more, than younger children. And crucially, they have a biological tendency to feel sleepy later in the day, and to need to sleep later in the morning. This is a biological thing. It's a developmental thing. And what that meant was that the pattern, especially in the US, but also in many other countries, of starting school earlier for high school kids was damaging the mental and physical health of children, of adolescents, essentially. And she started talking about that to any organizations that would listen, from psychological conferences to circadian rhythm conferences and so forth. And she exposed this epidemic of sleep deprivation among adolescents and launched this movement for later school start times, which now, just in the last few years, California became the first state to legislate later school start times for teenagers. Florida became the second state, and it's really become a global movement, thanks to this woman, Mary Carskadon, who never intended to become a scientist, and then just fell in love with this field and became so passionate that it took over her entire life.
Yeah, there were three reasons I wanted to save her for last, obviously chronologically. And she's the last limb on this family tree, which is amazingly so close together that it was just like a 4-person family unit. But lastly, because she's still around, which is lovely, but because she spent so much time talking to you, and your acknowledgments, you talk about how these sessions you had with her every Saturday for at least a couple, or between, an hour and 2 hours over a period of 3 months. And that's amazing that she gave you so much time. And it's obvious that it really helped you in framing the book itself.
Yes, it did. And she also, what was wonderful is, because this is a generational story, it's like Kleitman begat Aserinsky and Dement, Dement begat Carskadon. They were all around at the same time for a period. Mary Carskadon wound up playing bridge games with Dement and Kleitman, on a regular basis. She got to know Kleitman a little bit. And so she could give me observations on all the dramatis personae, and I also got to talk to Dement a few times before he died as well, on the phone. But yeah, she was incredibly generous with her time. And one of the challenges of the book was to remain objective about everybody, as objective as you can be, in terms of like not making it into a hagiography, but everybody I talked to loved Mary Carskadon. Essentially, she's been incredibly helpful to other people in the field, and she was incredibly helpful to me as well.
One of the things that Samantha Harvey said in that Times review was, one of the reasons why she thought the book was so good is because you weren't inside of all this. You weren't a scientist, weren't studying this, which just happened to be that article in Discover. And so you stood outside, and you're a journalist, and that gave, for her and for me, a better kind of perspective. So let me ask you one last question as we close, which would be, and it's kind of a trick question, is after you've done all this, was there ever kind of like a eureka moment for you in the book where you go, wait a minute, I think I have an idea about what this is all about? It's like people who have near-death experiences. And there's a new book by Sebastian Junger, the guy who wrote The Perfect Storm, about his near-death experience. And it's not the golden light or anything like that. It's more like a black hole. But in any event, and that's, people make that akin to sleep too. So my long-winded question is essentially, during this time, was there a moment where you had some kind of epiphany about what you were studying and the people involved in it?
Yeah, I mean, this is not an epiphany about sleep, because sleep, one of the things that became apparent to me as I researched this book over 7 years was that sleep is way too complex to give a single meaning to or to summarize. It's just the more people study it, the more complex it becomes. So my epiphany wasn't so much about that, but it was really about what was it that linked together these four very, very different people and the three generations of scientists that they represented. Because they're very different people. Kleitman, who was very uncharismatic and dry and scholarly. Aserinsky, who was very he was a troubled guy with a lot of anger. Dement, who is incredibly gregarious and sort of a real polymath and the kind of guy who can link together things from all sorts of fields. And Carskadon, who was this person who discovered her vocation and pursued it in this incredibly single-minded way, while also being sort of a support for so many people in the field, and sort of synthesizing what had come before in a way that really applies to all of our families and households. So what drew all these people together? And sort of it was a moment of finding an image for me. And it happened when I was visiting Carskadon's lab in the very last hour of the last day. At her lab at Brown University in Providence, she said, "Let me show you my basement storeroom." She has a house on the campus where she has her laboratory, and an identical house, both of which date to the 1920s, where she stores a lot of stuff. And in the basement of that second house were half a dozen EEG machines that she had used over the years, including a couple that she had brought over from Stanford in the 1980s that William Dement had given her as a parting gift when she went off on her own. He said, "Here, have a couple of EEG machines." So these were, machines that dated back to the mid 60s, and all of them were sort of big old clunky stainless steel things. And if you look at the technology that's used today by sleep researchers, it's of course completely transistorized. It's all microcircuitry. It's just chip technology, and it's very sleek and very miniature. These were big hulking mechanical machines, and I thought, wow, there's this strand of DNA that links these machines to the machines that Mary Carskadon is using in her lab today, which are things like EEG machines that are just basically a headband that you wear on your head. There's this strand, even though these things are so different, that links them all, and they have a similar purpose. And I started wondering, how could you define the strand that links the scientists themselves, from Kleitman through Aserinsky and Dement to Carskadon, and to Carskadon's students, who I also met during that trip. And I asked Aserinsky's son for an insight into that. And Aserinsky's son is now in his late 70s. He's become a clinical psychologist, so he thinks a lot about these things. And he said to me, "I think what they all had in common was a burning desire to know." And he continued, "And they were willing to go to hell and back to do it." And that to me is so simple and yet absolutely true. And that's how I ended the book. Spoiler alert.
I should just end the interview on that point, because that was really well said. I only want to agree with you, because science is hard, and it's hard whatever science you're in, but the idea of sitting next to somebody's bed and watching their eyes for 8 hours night after night is a Herculean task that I would never even want to attempt, right? Would you? Would you want to? They did?
Yeah.
Well, in any event, thank you so much for writing the book. Thank you so much for coming on the show. I really enjoyed it. And the best thing, as a bookseller, the best thing I can say about a book is, after I closed the book, I'm still reading it essentially in my head and going down various rabbit holes. So thanks.
That's wonderful to hear. Thanks so much for having me, and really enjoyed it.
Likewise. Talk to you soon, hopefully. Bye-bye.
Bye-bye.